Hi there, this is Koiro with a video with a slightly different topic than the last one I've published. I will branch into some topics that I want to go further in depth on in later videos, but what you see here in front of the camera now is actually my go-to test bench for old VESA cards, and this is a 386SX with an AMD processor, and this is an SX25 CPU, and it's clocked on 25 megahertz. And I also got a Matco coprocessor in this, so it's actually able to run some of the old CAD programs and stuff that needed the Mat coprocessor. And this machine also had a leaky battery, but it was removed early enough to avoid much damage, and the battery is replaced with a coin cell battery like this. And this machine, as it is configured now, has 4 megabytes of memory. And what's make this board special for me is that this sticker here, if you can see this, it's actually a warranty sticker for the Norwegian REC company. So this board has been in an original REC computer from back in the day, and you can actually see a serial number here. 12793 is the serial number. And the reason that I take this out now is that I actually will be getting a shipment from my brother with some old AT cards, some sound cards and some other stuff that I need to test. And this machine is normally coupled to one of these. This is an XT EDI adapter, and I normally put a flash adapter and a flash card on this, but this also works on other modules. I both have AT disk modules, and I also have some old hard drives that I can test this on. I actually have an installation for this machine with Windows 3.11, Windows 95 and DOS that I normally use to test things. I also have a GoTech permanently coupled to this, and this works okay. There are some issues with the parameters that needs to be set for high mem and other stuff to get rid of some error messages, and that probably could be solved with a BIOS upgrade. But the main reason that I'm showing this now is that I have this other card, which is a slightly more advanced board. This is actually also a AMD CPU, but this is an AMD that's clocked on 40 megahertz. And this board does not have cache memory either, so it's probably not that much faster. It also has a Mat coprocessor inserted, but this board actually has experienced some battery leakage. And I just got this board, and you can see here that it's green on this battery jumper connection here, and there are some marks on the board that it has been exposed to battery leakage. And the bottom of the board is just fine. So what I will be doing, I will be testing this board, and I will take out this battery, and I will clean up this area around the battery, and I will try this with an external battery. And if this machine works okay, I will use this as my test rig from now on. So that's the purpose of this video. I will clean out this board, and if we get this board up and running, we would change this on my test rig here to use this as a base for a test with all AT PC related stuff. The way this board is way smaller than the old one is also an added bonus, because then I can fix the GoTech and the power supply permanently to this base that I have established here, and this will be tidied up. So the first thing I do is I'm going to remove these memory sticks. There is no need for them to be in the circuit while we do the cleaning and other stuff. They will only be stressed if I do soldering and other stuff, because there always will be some static charge even though you protect yourself as much as you can. I will also remove the matte coprocessor, and as you can see, or probably not, there are some crud on the keyboard connector, and you have some diodes here as well that looks pretty green to me. So we are going to take out the battery, and we're going to neutralize the crud here by applying some acid. As you might know from watching other YouTubers, the leakage from batteries and capacitors is a basic or a base the chemical, so you have to neutralize it by adding an acid. But actually it also goes down to neutralize, and it's extremely difficult to mix a neutral solution of this. So when you apply acid to clean the base, that's a good process, but the idea that you neutralize the acid and neutralize the damage by using acid is, it might not a long-term solution, because if you actually make this sour by using an acid, you will continue the damage on the components. So the idea is to keep it almost neutral. It was very difficult to get some pliers into the gap, so I have to desolder the battery, and that's not something I like to do, because these battery terminals are kind of large and you have to apply some heat to get that out of the board. So it's better to always cut the terminals beforehand if you have the opportunity. Yeah, the battery was actually glued to the board, and that might not be such a dumb thing to do, because this glue will also protect the board underneath, I think. So now you can maybe see, I will try to zoom in a bit on this so you can watch the damage more closely, but we can actually see here that there are some corrosion on traces underneath here. So the question is those traces damaged or not? Yeah, I think this is the closest I can get without actually getting on top of something. I'm filming this with my Logitech StreamCam camera, and that's why you also see some lines in the picture here, because I really can't get this camera to make good shots. There are always some disturbances in the pictures like this, and I can sometimes tune them out by changing the intensity or the exposure or some tweaking, but sometimes it's just not possible. And we will try to wash off these areas, but we also need to scrape off some of the area here with the traces, and we need to follow these traces from one end to the other end if they look suspicious. These components here with the rather large holes and large traces, they will probably be okay. I think if we experience problems, it will be underneath the matte coprocessor socket, or underneath the keyboard socket, or the traces that runs through here. But first I will scrape away a bit of the crud, and then I will be washing this with some vinegar. There I removed the cap. This jumper here is for using the internal battery, and that means if I want to connect an external battery to this afterwards, it's just these two uttermost connectors, so that's really the best solution. Or I can use these terminals here, and then I just put this cap back on. Yes, I will just do some light scraping to see how deep this damage goes, and try to only scrape away the crud and nothing more. This green solder mask is really there to protect the copper from the elements, so it's not just there for cosmetic reasons. So when you scrape away the solder marks that's on top of these components, you do wisely to actually cover it up again. And there are some repair pens and there are some other stuff that you can use, but if you don't have any of the special things, you can use things like neutral nail polish or some other kind of lacquer stuff. It does not have to be the fancy green stuff, because when you have something that's plagued like this, it's not about making it perfect, it's about survival. So whatever you do to prolong the life of these boards, I think the ones that came after you and will own this after you will be very happy for the work you have done, even though it's not a perfect repair. As you can see, the solder mask is getting off real easy where you have this damage, and this is also the problem, because the electrolytics from the battery will actually try to seep underneath the solder mask if there is room. You know the truth about liquids, they will always try to fill a gap. So you can actually see here, this trace is bad, so the damage here is real. But if it's just this kind of damage, it's very easy to repair these kinds when you see it on the surface. The problem is that this is a 4-layer board, and the damage can be on vias, and it can be vias that should connect the layers inside the board that's defunct, and that's not an easy repair. Where I thought there was damage here just a moment ago, it actually looks like it's solid enough for it to work, because even though it's some slight damage, it actually can be damage from back when the board was actually produced, and that the solder masks just have covered it up. Because everyone that has tried to make their own boards know that there might be some defects and some inaccuracies along the lines. Now I will try to rinse this off with some vinegar, about 20% solution I think, and that I have to do off camera. Yes, and now for the moment of truth. I actually had one test run earlier and then the board stopped at an error code that indicated the display. It was the code 40 that was the last code checked, and the board was actually beeping 8 times in a fast rapid tradition, and that's normally on an older AMI BIOS. That means that the display card is bad. So I changed into another display card, and it might be an issue with the display card, but the other card I had was an older Trident card, and even though that card is working in other computers, there might be a compatibility issue with this board. So the next step will be to connect an XT IDE card to see if I can get this to boot into DOS, and then we can do some more proper testing. Now I've been fiddling around a bit with stuff here. I've connected my XT EDI device and connected the compact flash card and the adapter, and this is the configuration that I usually move about and use as a standard boot device if I test an old computer. And this is nothing extra, it's just set to boot into normal MS-DOS 6.22. And I've added the MAT coprocessor again, and I also placed the 2 last megabytes of memory, so now it's actually 4 megabytes. And I had some issue. I had to do a bit of a cleaning of the keyboard connector. It actually worked straight away, but I ran into some issues with stuck keys, and also I sporadically get a keyboard defect message when I run the BIOS setup. So I've cleaned it, and I'm going to clean it again with some deoxide or another electro cleaner. And also the VGA card had some issues. When I left this PC standing on my desk without power on for a couple of hours, I had to move the VGA card from slot to slot to actually get this working again. Now everything seems to be running quite okay, so I'm going to leave this powered on for a bit, and I'm going to run a burn-in test on this computer. Yeah, now when the computer boots, I'm going to press F5 on the DOS startup message to skip the setup files. I'm going to change into the Diag catalog and run the Diag's software. And in here I'm going to run a burn-in test. And now the program is looping through these tests, and it loops through these tests until we actually stops them. And the test that is being run through here, there are some hardware tests where you need some loopback connectors, and those of course will get an error, but the most important thing here is the memory, the interrupt controllers, keyboard controller, DMA controller, and the burn-in test, it meant to loop through this to get a result over time. So if there are some inconsistency, as we can see, there actually is some inconsistency here, because the software seems to think that I pressed a key. That's the error I just spoke about, with the BIOS detecting the keyboard device as bad. And I might have to do the cleaning of the keyboard port, or maybe I have to desolder the keyboard connector if there are some crud underneath that connector, or if some bad soldering or something. I will just run the test manually again and process. That was one pass done successfully. So I'm going to do the cleaning of the keyboard connector now before I do any further tests. This is the moment where I realized that this movie will be far too long if I'm going to continue the test in this episode. So I will make another episode where I do the cleaning and where I will show the final results of this test rig and see to that it's ready to test the cards that I will receive from my brother. So thanks for watching, and hope to see you again in the next episode, and please hit subscribe if you want to be notified when I post another video.